This video, we're going to be talking about 18.3 Objective 5, where we use the properties of inscribed and circumscribed regular hexagons to find unknown amounts. First question asks us to find the distance across flats for the figure to the right if GO is 17.32 millimeters and FO is 20 millimeters. So FO would be what I would use if I wanted across corners, because it's going corner to corner here, but I want across flat, so I'm going to use GO. I'm going to double it. 17.32 times 2 is 34.64. Just check that with my calculator. 17.32 times 2 is 34.64. ECO right here is going to be half of one of these angles of the regular hexagon. You might remember that that was 120 degrees there, and if we split it in half, we are making equilateral triangles here. So that should be 60 degrees, but let's prove it with our formula here. Half because we're bisecting it, so 0.5 times 180 times 6 minus 2 is 4 divided by 6 is going to be 60 degrees. And that's what we expected because we have equilateral triangle here with 60, 60, and 60. All right. Find the measurement of AB, which is this side right here. If I'm given that GO is 11.26 and FO is 13, well, the radius is the same thing as any one of the sides. So this is 13 millimeters here. This is for an inscribed hexagon. That the radius here, because this is an equilateral triangle, that this radius is the same as this side, and this side is the same as that side, and so on. All these equilateral triangles have the same measure, so the radius and the sides are the same. All right, let's find angle GOC. So GOC, we would have all of these angles here would be 60. Doesn't matter what the side was. And then I've bisected this, so these are 30-degree angles here. This is probably the most math intensive of the problems in this problem set. So the circumference of the circle is 114 millimeters, and we want to find the distance across flats here. So first I'm going to have to find the diameter or the radius, either by taking the circumference and dividing it by pi to get the diameter, or let's just go ahead and find the radius right away, jump down here by dividing the circumference by 2 pi. So let's take 114 divided by 2 pi. And that's going to be equivalent to giving me one of the sides of the hexagon. And then to find the distance across the flats, here it's going to be the same as the side of the hexagon times the square root of 3. And that formula can be found in your textbook. So this is going to be 31 point, they tell us to round to the nearest hundredth, so this is going to be 43. And then this is a distance, so it's in millimeters. All right, that's it for chapter 18, not just for 18.3, but we're done with chapter 18. So we'll come back next time and start our videos for chapter 19 with 19.1 objective 1. See you for the next video.